All right, guys. Today's goal, understand how to graph linear functions. You have seen linear functions written in the form y equals mx plus b. By naming a function, you can write it using function notation. So remember, the function notation means f of x equals mx plus b. So it's the same thing. F of x is the same thing as y. The symbol of f of x is another name for y, and is read as the following: the value of f at x, or simply f of x. It does not mean f times x. You can use letters other than f, such as g or h, to name functions. So it says evaluate the function h of x equals negative 7x when x equals negative 2. So this means h of negative 2 equals negative 7 times negative 2, positive 14. Okay, so let's take a look at another example. Here it's h of 7 equals negative 7 times 7, negative 49. So when they're asking you to evaluate, they're just saying plug in the number and calculate. Or plug in whatever's in whatever they're telling you to and substitute it in, calculate. Okay? So now domain and range. It says the domain of a function consists of values for x, for which the function is defined. The range consists of values for f of x, where x is the domain of f. The graph of the function is the set of all the points x, comma, f of x, which is also known as x, comma, y. Okay? So it says the gray wolf population in central Idaho was monitored over several years for a project aimed at boosting the number of wolves. The number of wolves can be modeled by the function f of x equals 37x plus 7, where x is the number of years since 1995. Graph the function and identify its domain and range. So, if you think about this, m is 37, b is 7. So remember, m is how you move, b is where we begin. So see how they began right here where it's 7, and then they went up 37 over 1 year, up 37 over 1 year. Okay? So now it wants the domain and range. So the domain. All right, normally a linear equation, the domain is going to be all your real numbers. But see, this is a word problem, so we have to think, okay? Can you see how it says that x is the year since 1995? So you're not going to go plug in negative 2, because they're not doing 2 years before, because they didn't start until 1995. So the domain has to be x is greater than or equal to 0, because it starts at 1995, which would be the 0 year, and moves on from there. Now the range, well, this is where the beginning point helps. We began at 7. So the range, f of x is, now this is where we have to figure out if it's, and then we have the 7 here. Well, does the line get bigger? Does it go up or does it go down? Well, left to right, remember, it's going up. So it's going to be greater than or equal to 7. Okay, now, so let's look at another way we can use these functions with this problem. See how it says, find when f of x equals 155? So see how the x is still there? So that means this x needs to stay there. But see how they have f of x here? So watch, this is 155 equals 37x plus 7. Now we got to solve for x. So you subtract 7, subtract 7. So that's going to be 148. Divide by 37, not 37x, just 37. You get x equals 4. So it's been 4 years since 1995, or it's 1999. Okay? Alright, so let's take a look at some other things that deal with function notation. Alright, so families of functions. A family of functions is a group of functions with similar characteristics. For example, functions that have the form f of x equals mx plus b constitute the family of linear functions. The most basic linear function of the family of all linear functions, called the parent linear function, is f of x equals x. So the parent function for lines is just the line f of x equals x, or another way of thinking about that is y equals x. Okay? So the graph of the parent function, the linear function, is shown. So right here. Okay? So let's look. It says graph and compare h of x equals negative 3x to f of x equals x. So let's quickly copy down the f of x equals x here. Okay? So if we look at this, f of x equals x. The slope is 1, the beginning point is 0. Okay? So we begin at 0, and then remember 1 over 1, so you move up 1, right 1, or you can move down 1, left 1. See how I completed the whole graph with the line? You don't just do this. That's not what you do, okay? You have to go the whole part of the graph. So let's fix that in. Okay. Now we need to graph f of x equals negative 3x. So the slope, negative 3 over 1. The beginning point is 0, so we're still starting at 0. But this time we go down 3, right 1. Up 3, left 1. Okay. Draw all the way through the graph. Now we have to compare them, so let's take a look. Alright, so we graph, now we just have to compare. So, again, their slopes are different, but both pass through the origin because they have the same y-intercept. Okay, so let's take a look at some things we can talk about when we're comparing. Okay, alright, so it says comparing graphs of linear functions with f of x equals x. So changing m or b in general linear function g of x equals mx plus b creates families of linear functions whose graphs are related to the graph f of x equals x. Okay, so g of x equals x plus b. See how it's still x? So their slope is the same. See how if b changes, what happens? They're parallel lines. So it says the graphs have the same slope but different y-intercepts. So they're parallel. Graphs of this family are vertical translations of the graph. And what they mean by that is, see how we start at the origin and vertically shifted up to, if you added to, or if it went down 1, 2, 3. Okay? The graphs have different positive slopes but the same y-intercept. So graphs of the family are vertical stretches or shrinks. Okay, here's the family. This is the vertical stretch because see how it gets up faster? This is the vertical shrink because see how it gets up slower? Okay. Here it says the graphs have different negative slopes but the same y-intercept. So the graphs of this family are vertical stretches or shrinks with reflection in the x-axis. So this is just going up consistent. This one goes technically down faster. If you go backwards, it's going, so it's a stretch. But it got flipped over. This one is the exact same slope, only it's negative. See how if I were to fold the paper over the x-axis, this blue line would match up with this red line. This red line would match up with this blue line, so that's why it's reflected over the x-axis. These are things we need to know, okay? All right, let's take a look at some more. All right, so it says a cable company charges new customers $40 for installation and $60 per month for its service. The cost of customers given by the function f of x equals 60x plus 40, where x is the number of months of service to attract new customers. The cable company reduces the installation fee to $5. A function that costs with the reduced installation fee is g of x equals 60x plus 5. So it says graph both functions. How is the graph g related to the graph f? That's in your book, you can read. Let's look at the next part here, though. It says, suppose the monthly fee is $70, so that the cost to the customer is given by is 70x plus 40. Graph f and h in the same coordinate plane, and how is the graph? So we are graphing this, and we're graphing this, okay? So the first thing we have to do is label our graph, okay? So we have, this is months of service. We're going to go 0, 1, oh, a little too far there. 2, 3, 4, 5, 6, 7. Okay, and then the other one is the cost, and this is per dollar. Okay, and if we go 100, 200, 300. Okay, so we've labeled our graph. So now let's bring the equations down. So we have h of x equals 70x plus 40. So we know the m is 70 over 1 and the beginning point is 40. And then we know f of x is 60x plus 40. Let's double check. Yep. So I know m is 60 over 1, b is 40. Okay? So if I graph f of x first, I know I'm beginning at 40, so that's 25, 50, so 40 would be approximately there. And then I have to go up to 60, so I'd be at 100 over 1 month. Do it again, I'm at 160 over another month. So it's going to look like that. Now if I go to graph the other one, again we're beginning at 40, but I go up 70 in over 1 month. Go up another 70, I'm at 180 over another month. See how the 60 became 70 and it stretched vertically more? Okay, so let's go back. What was it asking us to do? It says, how is the graph H related to the graph F? Well, H is vertically stretched compared to F. Okay? We'll see you guys in class.